the center of the Bunsen burner.
But I don't know
in the gas.
Wait, here's the first.
Gas is on. Now like the gas is kind of down. Right now we have a very not enough oxygen. So everything from this point up gets hot, from this point down stays cool. So I can grab this. Go ahead and open this up. We add more oxygen. Well, adding more oxygen now.
Solid piece of pure
What we're aiming for is a
metal.
nice light on the inside, dark blue on the outside. So we're going to add more and more oxygen. And all of a sudden, that nice turquoise.
Oh, are you in
That's
Physical
what
change.
Okay. This is still, you can kind of hear it's flickering a little bit. It means I've got a little bit high gas flow going. So I'm going to just back it down a little bit.
Yeah,
There.
Yeah.
Physical change.
Yeah. Now the sound going and to increase the gas flow from here. Add oxygen again. And I can get back to that same kind of flame. Now it's not flickering as much and I can't hear it. Right? That means I've got good gas flow. If you can hear it, it usually means more gas is flowing out than you're burning. So it's just okay. So now we're going to do with your copper wire. Got that nice shiny copper wire.
Colleen? You said 151.
And the hot part of your
Okay, I
flame
thought you said
is
one.
right at the top of that inner light blue cone. I do in and out of that for a little while. Put down thing. When you're ready to turn this off, we'll turn it off from the valve. Everything here is going to be hot for a couple minutes. Let it cool down for 3 minutes. Okay?
32.
Okay. First, keep going, add more oxygen. Keep going. Okay. First. Yes. Yep. And then we're ready for that? Okay. Yep. Keep going, keep going, keep going, keep going, keep going, keep going. We want a nice circle with this one on the inside or this one on the outside. There we go. Now you're flame about twice the height that we want. So back down. Close your gas. We want that inner blue flame to be about 1 inch to 1.5 inches high. You're about 3 inches. Yeah.
We're ready for that.
Okay. Anybody who's ready for the iodine demo?
That's the potential.
May I squeeze
Alright.
right in the middle here?
So,
Kinetic is just like
alright, we'll turn the light on. This is not the best way to do this demo for you, Felix, because normally I would do it with the warm water, but my water is not warm because I forgot to put on warm. So what I've got in this beaker is I've got, see this black crystal that's on the outside? It's sort of silvery. If you look at it, it reflects a little bit along the edges. You see in there?
I zoomed.
Reflects on the edges. Okay? That's solid iodine. Okay? So what we're going to do is we're going to heat that up and we're going to see what happens. And my water's warm enough. I can do it this way. So if I take this and I hold it in the warm water, let's see if the water's warm enough, otherwise we can do it right on the burner. It's not warm enough. This without melting the tubing. I let my water get cool. Let those crystals heat up. See what's happening inside the beaker?
Is it changing color?
Yeah. What's happening to the gas that's inside the beaker?
Just trying to, that there's just more of it.
Well,
It's
it is,
getting visual.
but it's purple,
Yeah.
right? It's not clear anymore, it's purple. So what we've got is the solid iodine is being heated up and it's turning into iodine vapor, which is the purple stuff that you're seeing. Okay? And it's not turning into a liquid in between. So you guys remember what that phase change is from solid to gas? Sublimation, right? It's what dry ice does. So what we're going to do is we're going to add another factor to it. This little dish on the top, I'm going to put some ice in, or there's no ice, so I'm just going to put some cold water in it. So now, as I heat up the solid iodine in the warm water, and I create that purple iodine vapor, that iodine vapor is coming up and it's touching that cold solid on, that cold dish on the top. So after a couple of minutes, you should be able to take this out, dump the water out. What do you see on the bottom? Not the brown stuff. Do you see this gray in between? You see how it's kind of sparkly in the middle, right in here? It's a little bit sparkly. We need to let it go for a little longer. But let's see if I can do it this way. We can heat this up directly on the burner so we can get a little bit more of our gas to form. I don't want to do this too much because this is really hot. So you can see a lot more of that vapor forming.
Yeah.
See if we just get a lot more vapor in there.
Holy moly.
There we go. So there's all that iodine vapor. That's neat. So now that iodine vapor is touching that cold surface on the top. So we'll regulate that a little bit with water. That's why I don't want to do it directly on the things. It's a little crazy. Now, let's see that we had a little more vapor on there. Let's see if we can. There we go.
Oh, wow.
See how that black that's on there? And if I move it a little bit, it sparkles ever so slightly. And what that is it's that same black shiny solid we had on the bottom, but now it's little tiny crystals that are growing on that cold surface on the bottom. So we went from iodine crystals on the bottom, we heated up, we got that purple iodine vapor. The iodine vapor hit the cold dish up here, and it started to crystallize out tiny little crystals of iodine on the bottom of that tube. So the question here involves, what's the reversibility? So looking at the copper reaction you just did in the flame, and looking at this little iodine reaction, it talks about the reversibility of a chemical versus a physical change. So if the copper, put it in the flame and it turned black, were you able to turn the black stuff back to shiny copper? Not really. You removed the black solid, but did you actually change the black solid back to shiny copper, or did you remove the black solid from the outside of the copper? You removed it. So if we're looking at that copper reaction, I can't take the black stuff that was on the outside and turn it back into shiny copper. That was a chemical change. I can't undo that. But this physical change, you watched me reverse it right in front of you. I went from solid to gas, right back to solid. So physical changes are always reversible, whether it's a phase change like this one, whether it's dissolving, melting, right? Any of those, I can always reverse it. Chemical changes tend to be irreversible. Once they've gone and made product, if I want to get them back to the original reactant, I have to do another chemical reaction to get them to go back the other way. So chemical changes tend to be not reversible. Physical is always reversible. Okay? Cool.
Thank you. Physical is always reversible?
Yep.